Hey guys, hope you have your computers out. I'd like you to get onto Edmodo and get you guys going on your assignment so you have the whole period to work on this. And then, depending on how it goes today, we have tomorrow as well. But I'd like us to make some good headway on this, see what you guys can do. On Edmodo here, if you go to your core geometry group, you're going to find this assignment that I made called Transforming Special Quads into Rectangles. There's two files. There's the Special Quads tool GeoGebra file. We've used that before, making our special quadrilaterals. And you also have this Word document here. Open this up. This is your assignment that we're going to paste screenshots into, and then you'll turn it in to Edmodo here. Okay, so let's take a look at the assignment. And the idea behind all of this is that we're taking the most basic area formula that we know in mathematics, and that is the area of a rectangle. I mean, look at this example here. We can't get any more understanding than this, that a 4 by 9 rectangle would have an area of 36, right? 36 squares would be in here. Basically, the idea, though, is that you have a base times some height, or a length times a width, whatever we want to call it. Basically just two numbers that if you put in a perpendicular array like this to create a rectangle, we could always find out the area of that. It's just base times height. The product, the multiplication of these two numbers, right? So the area of this would be 36. So we're going to take that fact and we're going to come up with equations for the area of some of these special quadrilaterals, like parallelogram, rhombus, kite, isosceles trapezoid, and trapezoid. This one, because there's not as much symmetry in a trapezoid, is a little bit trickier, but I want you guys to give it a shot. If this one you can't get done, that's okay, but I want you to try that one. It's kind of a challenge one. Okay, so for the assignment, there's under each special quad you have a table here with two cells in it. You're going to paste a picture of your special quad before you transform it, and then in the other cell you're going to paste a picture after as the rectangle. Okay, so we're going to do this one together here, the parallelogram first, but before I do that, I want to give you some pointers to think about when you're doing this. We're trying to construct a rectangle based off of our special quads, and they all are a little different. But the idea of a rectangle here is we have this shape where opposite sides are congruent and parallel. It has four right angles, four perpendicular relationships, right? But also I want you to think about symmetry. If we were to cut this rectangle in half, it's symmetrical. Right, we can see that, I hope, that the top and the bottom are the same, right, if we were to reflect. Okay, so what I want you to think about too is other special quads that have symmetry in it as well, because I can picture maybe like here, like a kite, for instance. If we connect, think of this as like the long diagonal of a kite. We have reflection properties, so we have equidistant, so really that kite's other diagonal, maybe I want to put it right here. It's bisected. So really now, here's a kite. Right? So that's what I kind of want you to think about, is now if we can do that, and you can see in these little rectangles that the kite makes, we've got some symmetry going on in here, and we can see how to transform the pieces of this kite so that we can make a rectangle. So think about shapes that have symmetry in it, right? Here's a couple examples. Here's that kite. So again, if you draw a line of symmetry, we can understand that even their diagonals are perpendicular, which is nice, right? Because we want that 90-degree angle relationship. And since they're on the inside, right, we have this 90 degrees here. Those are really bad, but 90-degree angles. But if we can actually like rotate maybe this triangle, we can make this 90 degrees rotate to the outside, right? Make the corner of some rectangle here, right? That's the idea. If you look at the rhombus, same idea here. Rhombuses have two lines of symmetry, so their diagonals here are perpendicular, right? And we can see that. So if you think about this perpendicular relationship inside again, we can think about transforming these inner triangles to create a rectangle, right? So keep that in mind. The parallelogram, though, when we make this, let's just make a parallelogram. So go to your GeoGebra app here, and grab your parallelogram tool and just make yourself some parallelogram, right? We could make this look like a rectangle based on its height, but let's make one a little slanted here. Okay, how do we make this into a rectangle? Let's see here. Okay, so if we look at the diagonals of this parallelogram, maybe. Let's get some kind of idea of how we're going to construct a rectangle based off of this. The diagonals in a parallelogram aren't perpendicular. They don't have that 90-degree relationship like that rhombus and kite did. So, doing this and trying to transform these aren't going to do us very much because we're not making 90-degree angles that can be transformed to the outside corners to make a rectangle. So what we can do, and I'm going to get rid of those, maybe we don't need to go diagonals in shapes that aren't as symmetrical, even though they are symmetrical. They have rotational symmetry on a parallelogram does on this diagonal here, right? You can't reflect one half to get on the other, but we can rotate. So that's another thought that we can do as well. So let's create a 90-degree angle. Okay, so what I want you to do, if you're following along with me, is create a perpendicular line. The height, basically, is what we're going to create of this parallelogram. So we have to treat one of the sides as a base, right? Maybe like this green side. Because for me, when I look at a base of a shape, I always think of like the bottom side. Okay, this is kind of how I think. But I want to create a side that's perpendicular to this green side. So I'm going to use my perpendicular line tool. I'm going to click on this green segment to tell GeoGebra I want to be perpendicular to this. And I want to go through, I can either go through A, right, or I can go through C here. Maybe we should do both. So we can kind of see some 90-degree angles that we can eventually get transformed out to make a rectangle. So notice we have a 90-degree angle here based off of that perpendicular construction. Okay, let's do the same thing here. I'm going to do another perpendicular line to this green segment, but I'm going to go through C. So now what we have are these two triangles on the outside here that are right triangles because they have 90-degree angles in them. So maybe we can get these things transformed. So I need this angle way over here to make a rectangle, right? So, and I need this one, this angle over here. So let's first of all make a polygon. So grab your polygon tool, and we're actually going to make a polygon on the piece of the shape that we want to transform. Okay, I'm going to make one for this one over here as well. So I'm going to transform that too. Okay, so now if we think about how we're going to transform this piece out here to make this 90-degree angle go down in this bottom corner to make a rectangle, it could be a reflection, maybe a rotation, definitely not a translation. So if it's a reflection though, and when we think about reflection properties, you got to think equidistant and perpendicular. So E, if it gets reflected, would follow some perpendicular path that's equidistant to the line of reflection. So E would actually end up like right about here somewhere, right? If we eyeball that, make a kite. Okay, so that's not what we want to do. So if we rotate to get E out here, that seems like, 180-degree rotation centered, at the midpoint of this segment. So I'm going to grab my midpoint tool. I'm going to create the midpoint here. I'm also going to do the same thing over here. So I'm going to create that midpoint since I got the tool out. And then we're going to go ahead and rotate these pieces. So I'm going to rotate this polygon about G. If it doesn't work, I just hit escape on my keyboard. Highlight the polygon. There it is. Rotate around that midpoint 180 degrees. Hit OK. Hey, look at that. Now we have a nice shape here, right? We have a 90-degree angle we just rotated. Okay, we could argue that this is 90 degrees as well. Okay, and let's do the same thing over in this polygon, this triangle over here. So I'm going to grab that rotate tool. I'm going to click on my polygon, click on that center H, rotate 180 degrees, and boom, there is a rectangle, right, that we made based off of this original parallelogram. Okay, so oh shoot, I forgot to take the screenshot of this before the rectangle. Here's my screenshot though of making the rectangle of the special quad. So I'm going to hit print screen. Okay, and then on my Word document here, I'm just going to, in the second box here, I'm going to paste it. We probably need to shrink these pictures a little bit so we can get them side by side. And then we need to get that picture of the parallelogram before we did all this stuff. Maybe if I hit back a bunch of times. There it is. And I'm going to hit print screen again. I'm going to capture this, copy, paste this in my first cell, and shrink it so they're side by side. And I'm done with the parallelogram. I took a parallelogram and we made a rectangle using some symmetry thoughts. Okay, so good luck. You have the rest of them. There's 4 for you to do for the rest of the period. Good luck, guys.